Myself. All right. So anyway, welcome back. It's National Golf Day. On this day in 1957, the Soviet Union launched Sputnik 1, and it made everybody terrified. Like, oh man, we got to get to space first. And so it started the space race, which culminated in our people landing on the moon, right? 1969, 12 years later. Happy birthday, Rutherford B. Hayes. How many of y'all know who Rutherford B. Hayes is? Yeah, right. He was a cool dude, wasn't he? What did he do? Oh, you couldn't. He was one of the presidents of the United States of America. Yeah, yeah. He's right there in the middle of the. He's like the bearded section of the presidents. And I wore this Metal Monday shirt today because it's from the 2019 Legacy of the Beast tour. And what's that? Oh yeah, I went. Yeah, yeah. Heck yeah. When they play in San Antonio, I'm there. So anyway, it's Eddie, and he's taking Mount Rushmore, and he's maybe it's a different mountain, and he's putting the presidents all with Eddie faces, the mascot Eddie. It's kind of cool, and so it's apropos because not only is it Metal Monday, but on this day in 1927, Hergbin Borglum, the guy's name was Borglum. His first name was weird too. He began carving Mount Rushmore on this day. He went up to the rock, and he's like, I guess we're gonna have 4 presidents, and it took him how many years? 14 years. He finished in 1941. So there you go. It's like a double entendre shirt. Metal Monday, and yeah. And then the word of the day is Weltanschauung. They borrowed it from Germany. It's basically the feeling you have in your relation to the world, okay, the universe, and our place in it. So, haben Sie ein Weltanschauung? If not, that's okay. And then the QOD, I put a new one up there. Look at that, QOD, quote of the day. It's going to be kind of like maybe a thought-provoking, humorous one. Work is accomplished by those employees who have not quite yet reached their full level of incompetence. Yeah. So that reminds me of another joke. Like a guy goes up to a CEO of a large company and says, hey, how many employees work here? And he says, oh, about half of them. Bluford. Yeah. Are we gonna have that stand-up comedy thing? Is that going well, I talked to the guy that was supposed to be in charge, that was supposed to get the ball rolling. He's like, no, I didn't. I can't do it. So I do want to start it though. But I'm gonna start it myself now, and I guess we'll have to vote for officers. I was gonna appoint him president and have him get the ball rolling. But yeah, Dr. Presley could be like a guest speaker someday, right? Anyway, no, I am going to get that going. But speaking of clubs, again, just for the video that hopefully won't ever get deleted off my computer when I delete the download. How do you get rid of the download folder and it gets rid of all? I had it anyway. Apple products. This Wednesday during advisory, we have math club meeting in here. And then next Wednesday after school, not this Wednesday, next week we have a creative coding club that meets in Mr. Bellevue's class. So anyway, if you want to do either of those. All right, let's go through the test. The retest is tomorrow. The retest is tomorrow morning. Get here by 7:50, 7:45 when the doors open. Give yourself a full hour, okay? That's when the retest is. Remember, on the retest, there's no curve like there is on the regular test. So you can figure out what your curve is. Take the number you got right divided by 16 times 100, right? And you compare it to what I gave you. There's no curve on the retest. And remember, there's also no multiple choice on the retest. The multiple choice turns into short answer, where notation is now important. But here's the flip side of the coin. You know exactly what the problems are going to be, and you know the order they're going to be in. Because on the front, it's the exact same questions. I don't change anything. I just get rid of the answer choices, okay? So you know exactly, number one is going to be this problem here. And you know exactly how to do it because we're about to go over it. And on the free response, I just changed 1 or 2 of the numbers around. We'll talk about that when we get there. All right, so if you make at least a 70 on the retest without a curve, 70%, you can get your grade that was below a 70 replaced with a 70. Now remember, I said if you make 100 on the retest, that impresses me. And there were a couple people last time that came in and retested that made 100 on the retest, and sure enough, I gave them bonus points. I've been known to give 73, 75s. Yeah, and if you don't fail, can you still come and retest tomorrow if you made like an 80 on the test? Sure, right? When you come and do something that you don't have to do, especially when you do it well, I'm like, man, this person is going above and beyond. And when you go above and beyond, like Macy and Garrett, you're going to get rewarded, right? It may be like later down the line, like when they count the votes or something, but yeah, always going above and beyond, going, not just meeting the minimum standard. I appreciate students who do that. So yeah, if you made a 99 on the test and you come in and retest tomorrow morning and you make 100, I might give you a 102. It's just like, yes, yes. All right. So here we go. Expand and simplify. So to expand this one, you need to put everything in a power of x format. The second factor, 3 minus 2x squared, is good to go. But the first one has a variable in the denominator and a variable under a radical. So your first step is to bring this x to the top and say it's to the negative first, and write that one as x to the 1/5. Now, tomorrow on the retest, if you're taking it, and if you can't make tomorrow morning, remember, just let me know. Several are taking it tomorrow after school. I want to see every single step. So here it is rewritten, 4x to the negative first minus 2x to the 1/5, and then I rewrote the second one. Now, you'll have space tomorrow to work straight down vertically. It's an expression, so you don't even need an equal sign. You can FOIL if you want. Remember, I don't like FOIL. I like just distributing. I like starting on the first one, and then I distribute to both of the others. So if you get in the habit of doing numbers first and then variables second, you compartmentalize it, okay? 4 times 3 is 12. Got it. And then x to the negative first times no x is just x to the negative first. Boom. Now distribute the 4x to the negative first to the second one. Numbers first. 4 times negative 2, negative 8. Got it. X to the negative first times x squared. Add exponents, right? Negative 1 plus 2 is 1. Boom. Then we move on to the second term in the first factor. Negative 2x to the 1/5 times 3. Do the number. Negative 2 times 3. That's negative 6. X to the 1/5 times nothing is x to the 1/5. We got this. And then finally, this one times that one, number first. Negative 2 times negative 2, positive 4. X to the 1/5 times x squared. This was the most fun one on here. We have to add the exponents. 1/5 plus 2, 1/5 plus 2. 2 is how many fifths if you multiply by 5 over 5? 10/5, right? This is the level I want y'all to try and force yourself to be at, doing it in your head. 2, if you multiply by 5 over 5, is 10/5. So 10/5 plus 1/5 is 11/5, okay? If you need to do that off to the side, that's where you do it. Now, all you got to do is go back through and put everything back in original format. No negative exponents, no radicals, okay? Now, when you have x to the negative first, some people on their work, I saw, they bring x to the bottom, but they bring x to the bottom of the whole thing like this. They say, okay, it's 12 all over x, and I did it with a highlighter, okay? We don't do that because this is only the first term, right? That x to the negative first goes to the bottom of that term only. And so if you want, remember, you can put this over 1. Oops, that's way too much. That's not a highlighter. That's just a really thin pen. Put it over 1, and now you give yourself a bottom bunk where you could bring the x to the negative first. So anyway, that's what it cleans up to be. There's no like terms. So x to the 1/5 is the 5th root of x. X to the 11/5 is the 5th root of x to the 11th. And then you look, and there's a couple of them that are candidates. But alas, when you carefully analyze each term, it comes out to be A. All right? So tomorrow on the retest, this is where you'll stop, right here, okay? This bottom highlighted line. And you'll show all the steps. Inch by inch, it's a cinch, right? We memorize strategies by practicing strategies, okay? We don't like memorize numbers. Like, don't go home tonight and memorize this number sequence, right? That's way too hard. Just memorize strategies, and then once you know the strategy, get rid of all your negative, put denominators into the numerator, get radicals as fractional exponents. That's one strategy. FOIL if you want, that's another strategy, and then put it back. That's another strategy. You memorize those, or you get good at them by practicing. Okay. Any questions on number 1? That was a good one out of the box. All right. Number 2. Find the domain of k of x. Hey, I like k of x. So we have a square root in the numerator. So that has to be greater than or equal to 0 under there. And then I have a variable in the denominator, up to 2 values that give me division by 0. So not surprisingly, we have our 2 cases. So I start with the radicand from the square root. Negative 5x minus 23 is greater than or equal to 0. That's linear. That's linear. Add 23, divide through by negative 5. What do you do when you divide through by a negative? Flip the inequality, right? So now x is less than or equal to negative 23 fifths. If you're not sure what negative 23 fifths is, go off and do long division. It's about negative 4.6, okay? So that's kind of helpful. All right, now for division by 0, we take the entire denominator, say it can't be 0, and then we factor it, and then we get our 2 roots. We don't have to label it as roots because when we set it equal to 0 or not equal, that's what we're getting. So we get 5 and negative 3. We only need to exclude something if it falls in the inequality interval. We don't doubly exclude anything. So that's why it's nice to know that negative 23 fifths is about negative 4.6. Is 5 to the left of negative 4.6? No. Is negative 3 to the left of negative 4.6? No, it's to the right. So both of these fellas that cause the 0 in the bottom, they're already out. They never even come into play because we have to look at negative 23 fifths and to the left. So we don't doubly exclude them, and then there's your answer. Of course, tomorrow on the retest, you're not going to have multiple choices. So notice how we start you off here with the domain, d sub k colon. You'll just add that tomorrow. D sub k colon, that's like you declaring your final answer. And I don't care. If we have interval notation as an answer choice tomorrow on the retest, if you take it, you could use either one again, okay? So here's set notation or interval notation. You would just have to add d sub k colon to answer choice E. And remember, also see if you can remember to put x epsilon on that interval notation, okay? You won't necessarily lose points if you don't have it. Combine the results. All right, any comments or questions on number 2? Number 2. All right, so we're moving through the test, right? The clock is ticking, but it doesn't bother us. We're in good shape. All right, letter C, or number 3, sorry, the answer is letter C. Simplify. So we have a complex fraction, and we know it's a complex fraction because we have negative exponents in a fraction. Step 1 that I taught y'all is to get rid of the negative exponents, okay? So this is where you can give the top left a bunk bed, the top right a bunk bed, bottom left, bottom right. There's 4 terms. Give them each a bunk bed by putting them over 1. Bring in each term the negative exponents to the bottom. All right, now again, I'm working left to right here because this is my key. Tomorrow, if you're retesting, you'll be working straight down, okay? So you'll get this green line right here. Now you look for the LCM. You look in your bottom bunks, your miniature denominators, yes? And you look to see what the LCM is. Well, remember, you need at least 1 of each factor type. So I need an x and a y. And then you take the largest exponent on there. So that's x cubed y squared. I put it over 1. Now, what you do from there, you know, there's a lot of different ways you could do it. I showed you how you can physically take another line and rewrite the LCM and put it behind each of the 4 terms so that you can divide things out. I also taught you that you could, if you want, just multiply straight across. Instead of dividing first, multiply straight across. 3x cubed y squared over x cubed y squared over 1. And write it 4 different times and then divide out. I want you to get the right answer. But I also want you to stretch yourself to grow. This is an honors class, right? And looking out, I do see some honors people. In fact, every one of y'all is an honors person, right? If you want to see a good honors person, then on your way out, just stop over here and look in the mirror. Oh, yeah, there's an honors person, right? Yeah. Okay. So try to distribute in your head and divide out. So when you do that in the first term, your x cubed y squared, they both divide out. So you're left with a 3. That's it. In the second term, only one of the x's divides out. So you're left with a negative 2x squared. One of them's gone. And then y squared times y squared is y to the 4th. Okay, and the bunk beds are gone. In the bottom, you distribute. One of the y's divides out. So you're left with x cubed times x cubed, x to the 6th, and the single y that's left. And then finally, in the bottom right, nothing divides out. So you're just left with 3x to the 4th y squared. And that's it. That's your answer. That's as far as you need to go on the retest tomorrow. Remember, after this, we do attempt usually to go further. by factoring, but nothing factors out in the top other than a 1 or a negative 1. Now in the bottom, you could factor out an x to the 4th times y. And so if you wanted to do that, you could, but nothing would divide out after that. So if you ever go past where you're supposed to, it has to be correct. Otherwise, you can lose a check. So I'm telling you, on the retest tomorrow, stop right there. No need to factor the bottom, okay? And of course, that was answer choice C, and you have to look carefully. It's almost easier on the short answer because you could stop here. You don't have to like diligently cross your eyes and look to see, like those hocus pocus puzzles, you know, like what's the difference between this picture and the next? I hated those. It always like, it made me aggravated, right? That's kind of what we're doing here. We're trying to find the matching answer to our answer. Yeah. Hello, Sizer. Come on in. We're going over the test. We're recording. And Mackenzie's back. Yeah. All right. So any questions on number 3? Number 3. All right. Number 4, the domain. Well, we've already worked the domain problem. So here's another one. I factored the denominator for you. You're welcome, right? Because the leading coefficient would have been a 20. And I have a square root in the top. Remember, the only time the numerator concerns us is if it has an even root radical, square root, fourth root, etc. So once again, we're going to set up both cases. And I have room, so I did it down here. This left column, that's the radicand. 7x minus 4 is greater than or equal to 0. Add 4, divide by 7, x is greater than or equal to 4/7. And of course, you'll test it, right? I'm not going to do it now, but you'll pick a number to the right, like 1, it should work. You pick a number to the left, like 0, it should not work. All right, now for the denominator, you set them both not equal to 0, and if you need to do that, you can. Here's what I would like for you to be able to do at this level. Instead of physically setting each one of these factors equal to 0, just know that the root is going to be solved the same way you would algebraically. Just in your head, bring the negative 1 across, which becomes positive 1, and divide through by 5, and you get a 5th. Next one, bring the negative 3 across in your head, it becomes positive 3, and then divide through by 4, you get 3/4. Some people, when they do it in their head, they forget to change the sign, right? It should be the opposite sign of what you're looking at. If you need to physically do the algebra, off to the side. All right, now, this is a good question because we have to compare fractions. I only want to exclude those two guys if they're bigger than or equal to 4/7. Well, unless you have a real intuitive idea of what a fraction value is, it's best or easier to compare fractions when they have a common denominator, okay? And so the common denominator doesn't always even have to be the least, right? You can always get a common denominator by multiplying them all together. So 5 times 4 is 20. 20 times 7 is 140. So convert it. 4/7 is the same as 80 1/40. You just multiply by 20 over 20, right? So you get 80 20ths. We only need to delete those if they're bigger than 80, essentially. All right, 1/5, how do you get that? You multiply by 35, or 28, sorry. 5 times 28 is 140. 1 times 28 is 28. So is 28 bigger than 80? No. Smaller than, so he's already out. 3/4, okay, you multiply and you get 105. 105 is bigger than 80, so you do need to exclude it. So 3/4 is bigger than 4/7. So now, when you write it, it looks like this. And of course, tomorrow you'll do D sub F colon. I don't have that here because it's written at the top. Start at 4/7, cruise to 3/4, step over it, go to infinity, but a beefy bracket at 4/7. Or that is the set equivalent right there. D sub F colon. Okay. Fractions, fun with fractions. No one in here is afraid of fractions anymore, right? No one's going to go like for Halloween as a fraction and try to scare people. Or maybe you could, maybe people who aren't in this class, right? But for you, fractions are not scary anymore. You've had so much practice with them. Fractions are just numbers too. They just want people to love them. And no, fractions are not scary. Oh, a second. Okay, good. All right, any questions on number 4? Number 4. Have you ever seen a guy wearing red pants before? Probably not often. I'm wearing them today. Yeah, red pants. Are they? Well, they're kind of new. I got these like a while back, but I've never worn them before. But I thought today would be a good day for red pants because they match the red and the, yeah, red pants. Okay. Yeah, I mean, there's no mistakes. There's just happy accidents.
That's right.
Right. So if it looks orange to you, it's just a happy accident. All right, number 5. All right, so this is like what I call the Inception problem. H of H of H of X. We're plugging it into itself several times. You don't have to take one big bite, all right? H of X is 2 input minus 3. What I did is I focused on the inside. I just broke it down into H of X, all right? So what is H of X? Well, it's 2 times input minus 3. And in place of X, I put parentheses. So it's 2x minus 3. But in place of X, I put a H of X, which is another 2x minus 3. So that's 2 of the 3 layers. Now I'll distribute the 2. Simplify, you get 4x minus 9. Now all I got to do is one last time plug 4x minus 9 back into 2 input minus 3. So then the next column, notice I wrote it out again. This is what it's equivalent to. H of X then is now 2 input minus 3 again. But now I'm plugging in for my input what I've already simplified, 4x minus 9. And once you get that far, then it's a matter of distributing, collecting like terms. If you got this far and you made a careless mistake at the end, like sometimes I do, like if you have minus 18 minus 3 and you just write down minus 2 instead of 21, that's something I would do, right? It's like, oh, all I need is a 1 and I leave my brain leaves and my hand finishes up and it forgets to write it. This is an all or nothing problem, right, on a multiple choice, but on a retest, I might say, hey, you've demonstrated, you've communicated that you know how to do this type of problem. Careless mistakes, we got to work on that. And that's something I'm always working on. So I might not take off, right? What do you like better, apples or raspberries?
I've never been a big raspberry fan, but these are good.
They're not bad, are they? Yeah, yeah. All right, questions on number 5. Number 5. We're rolling through the test. Rolling, rolling, rolling. Number 7. Let b of x equal that, and j of x equals x squared plus 6x plus 4. Evaluate b of j of negative 2. B of j. Some people first period snickered when I said b of j. That's what the O means, right? Think of like BJ's Brew House, right? There you go. Name a whole restaurant after that. Of negative 2. That's the condensed version. What I would do is write it in expanded version, right? It makes more sense to see b of j with parentheses. All right. Now you could divide and conquer. If you want to go off to the side and figure out what j of negative 2 is, like I did in the previous example, work it out, bring it back in, and then evaluate b of that. I'm going to do this one all in line together, but notice what I'm doing. I'm not going to go ahead and write the b function there, right? The b function is the square root of 4 minus 2 input. I'm not doing the square root of 4 minus 2 input of all this. I'm just leaving it as b. It's a placeholder for what I'm doing next. But I am plugging negative 2 in to the j function. So instead of x squared plus 6x plus 4, it's negative 2. And then I'm simplifying and I get negative 4. And now I need b of negative 4. So now I plug it into the b function, again working straight down. 4 minus 2x. Oh, your parentheses are so important there. Because if you put 4 minus 2 and you plug in a negative 4, first of all, if you just leave it like that, is that multiplication? No. But even if you put a dot, like some people put a dot, that's multiplying. Ooh, I'm going to do what Papa Bear does when he finds Goldilocks in his house. Right? Because that's bad form. That looks bad. That is so easy to mistake multiplication for subtraction. And the whole goal in here is to communicate what we're doing. Parentheses are your best friends in a math class, okay? And don't trespass either, right? Like Goldilocks. She's a criminal. But I guess it was a TikTok challenge, right? Sneak into a bear's home. All right, you simplify and you get square root of 12. Now, tomorrow on the retest, square root of 12 simplifies. It's 4 times 3. 4 is a perfect square, so pull the 2 out. Or go off and do your prime factorization. Remember, it takes 2 factors of each on the inside. to be 1 on the outside, okay? There you go. Comments or questions on that one? Divide and conquer. Inch by inch, it's a cinch, right? Mile by mile, it's a trial. Eat that elephant 1 bite at a time, right? And the whole time say, elephant. Elephant. Yeah. Yeah, I haven't either. A lot of people have had buffalo or bison. I don't know if elephant is a delicacy in other places, like France. Yeah. Yeah. Did I make a mistake? Number 6. Oh, my goodness. My goodness. Sometimes I get ahead of myself, literally there. Yeah. Yeah, I know. Okay, so let's backtrack to number 6. Rationalize and simplify completely. Rationalize means to get the radical out from where it currently is to the other side. I spy a radical on the bottom, therefore it needs to be out of the bottom and into the top. If it were just the square root of x plus 12, I would multiply by the square root of x plus 12 over square root of x plus 12. But it's part of a 2-term dude. So what do I do when I have a 2-term dude? I have to multiply by the what you get over the what you get? Conjugate over the conjugate. Very good. That clue always helps, right? Now, to get the conjugate, you don't change the sign under the radical. You just change the sign between them. So the conjugate of 4 minus radical is 4 plus radical, okay? Now, when we do that, this is what we get. And this is what you write tomorrow if you're retesting. 4 minus radical. Now I have 4 plus radical over 4 plus radical. Make sure you show the division sign in between there. Don't just let them hover. The goal is always, always, always to expand the 2 conjugates, to multiply them out, always. But on the other side of the fraction, in this case the numerator, the goal is the opposite. The goal is to factor, 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 okay? We always want to expand the conjugates because by design, the middle terms will cancel. But on the other side of the fraction, we want to factor. And remember, the first rule of factoring is to pull out a common factor. So 3x squared minus 48, you pull out a 3, and now you're left with x squared minus 16. So I did that from one line to the next. And now we go to the next line. X squared minus 16. Ooh. That's a difference of 2 squares. It factors into the product of 2 conjugates. Times this leftover factor that was from the denominator, radical or 4 plus radical x plus 2. Now, in the bottom, this is where you want to be very, very careful. Actually do the math. First, outer, inner, last, that's fine if you want to do that. I like to just distribute. 4 times 4 is 16. Write it down. The inner and outers, I would not recommend writing down. When you do conjugation, it's too much writing. But look what happens. On the next distribution, 4 times radical, you get positive 4 radical. And then you move over to the next one. Minus radical times 4, that's minus 4 radical. 4 radical minus 4 radical, 0. They're gone. But now on the last, you need to be real careful. Always do the number or the sign first. A negative times a positive is a negative. And then look, a square root times a square root gives you the radicand. Notice what I have the radicand sitting in here? Parentheses. That's hugely important because you're subtracting now a quantity. So you either get in the habit of putting parentheses around your quantities, or you know that this negative can be distributed. And as you write it down, you go ahead and do that. Minus x minus 12. That's a real easy place to make a careless mistake. Minus parentheses. Okay? Now notice the top is completely factored. It has a radical in it, but is there a radical on the bottom anymore? No. So now it's just cleanup time, right? The top is good. In the bottom, if I distribute, I know I'm going to get a negative x. I'll write it first. And then 16 minus 12 is positive 4. And you think you're done, but wait. I have a negative x plus 4, and in the top I have a positive x minus 4. Are those the same? No, but I can make them the same by doing what? Factoring out a negative. Yeah. If I factor a negative out from either the top or the bottom, it doesn't matter. I chose the bottom. That's going to change both signs. If you want to redistribute the check to see if it works, it does. Now, by doing that, look what happens with your x minus 4s. They divide out. And now it's just careful inventory. When the x minus 4s divide out, what are we left with in the bottom? What kind of one? We're left with a -1. And that can easily get lost. The negative that I factored out still is there. The x minus 4s are gone. So let's combine all three of your factors. Well, dividing by -1 is the same as multiplying by -1. What's 3 divided by -1? -3. And so I pull that out front, and then I have the other two factors, and I leave it like that. I'll say on the test tomorrow, leave your answer in factored form. Because really, if you expand it, there's really nothing else we could do. There's nothing to divide out anymore. Okay? So, man, that would be horrible if you divided it out and you lost the negative there. All right? That's a good one. Thank you for making me come back to it. I don't know why I skipped it, right? I should have skipped up to it like, here I am. Let's do the problem. Oh, look, see, I know you're looking over here, right? Here's my my first draft of a retractable screen for the Windows. So I keep taping stuff up. I currently have it taped, but I bought this cute little clip that I screwed into the door. And so watch, just with a quick release, you know, there you go. Yeah. But I'm going to make it out of cloth. I'm going to choose like some material and I'm going to sew it. And then I'm going to permanently attach it on the top. And then we'll have a little clip. And there you go. All right. So we're ready for lockdown mode, baby. Hopefully I'll never have to use it. But I'm not scrambling, taking Coach Fair's golf schedules and taping them together. Right. All right. Any questions on that one? Number 8, which of the following doesn't represent a function of x? Remember, the ultimate litmus test is, can you solve it for y as a function of x? But you can tell just by looking at the exponent on the y. Remember, it tells you the maximum number of solutions you'll have for each x. So if you look at all the exponents on the y, a half, 1, 1, and 1, a, b, c, and e, they're all 1 or smaller. But if you look on d, you get y squared, okay? So we thought that would be a real easy one. I put the new hall pass on the candy cane. Yeah, because I didn't want to just scrap it, so I wrapped the lanyard around the bell. So if anyone asks, to say it is official. Yeah, all right. Okay, so that's the answer, D. It has a y squared. Now on the retest tomorrow, I'm going to have you actually. I can't make a, you know, what would you do with this one if the answer choice is gone? I'm going to have you write an example of one function of x and one that's an equation that's not a function of x. One equation that is a function of x, one equation that's not. Could you use answer choice D's equation for your example of one that's not? You certainly could, but that's a lot of memorizing, right? Could you use A, B, C, or E as your example of one that is? Yeah, but that's a lot of memorizing. I would just come up with one. Give me an example of one that is, just off the top of your head. What's that? Y equals X. Kaboom. Yes. Yeah, piece of cake, easy, right? You don't even have to call f of x equals x. You can say y equals x. Money, boom, in the bank. Now, give me an example of one that is not a function of x. Y squared equals x. Done and dusted. Done and done. That's it. Kaboom. See? Easy. All right. Any questions on the multiple guess? Choice, multiple choice. Any questions? All right, now it's time for the free response. So remember, on the free response, it's the exact same layout, same questions, but I changed the numbers up slightly. So F, instead of 2x minus 1, it might be 1 minus 2x. G might be 5 minus 4x, the cube root of, so on and so forth. Other than that, it's the same. Now, these are each worth 2 checks, 2 apiece per section. It says to set up and simplify the equation, right? Equation is bolded. I told you before the test, you needed an equation. Some people still lost points here. All I wanted you to do was to set it up with an equation, meaning P of X equals, or W of X equals. Don't just have an expression floating around if you're going to be talking about it, working with it. You need to give it a name. I gave it a name, P of X, okay? I could have taken off each time because your first check is just for the setup, but I decided that you can only lose a maximum of 1 check for having it not there on any one of the 3. Like some people had the name on 2 of the 3. right? P of X equals, W of X equals, but on part B, they forgot to put R of X equals. Well, they lose a check and that's it. If you didn't put it on any of the three, you just lose one check and that's it, all right? So the first check was for the setup on A, B, and C. That's pretty dang easy, right? You're welcome. Now, to find the domain on this one again, let's look. Same situation. Square root in the top, radicand has to be greater than or equal to 0. Solve and you get x is greater than or equal to a half. It's not quadratic. You solve it pretty easily, and there's no need to flip the sign. The entire bottom can't be 0. Now, some people said the entire bottom can't be 0, and then they left it blank under there. I'm guessing they saw a leading coefficient of 2, and they're like, I can't factor it. The leading coefficient is 1. I can't factor it. If that was you, and you wrote this down, but you didn't proceed, and it wasn't a time issue, then you need to come see me, because we need to get you, first of all, to learn how to factor when the leading coefficient is not 1. But secondly, we need to talk about violating the only rule I have in this class, which is to care. Because if you walk in and you don't know how to factor something that's not a leading coefficient of 1, you're telling me you don't really care, and that's not good, okay? Because we talked about all kinds of different ways, right? Guess and check, snowflake method, split the middle term. Sure, it might take a little bit of effort, but you could do it. I chose 2 numbers that were prime, 2 and 3. So it really had to factor only one of 2 ways, all right? But anyway, you get down, you get negative a half and negative 3. Are either one of those bigger than 1/2? Well, negative 1/2 is not, and negative 3 is not. So you don't need to exclude any one of them. Now, here's the deal. Tomorrow on the retest, if you just assume that they're not going to be excluded because they already are, you still have to show this work. You have to show me your thorough analysis, okay? These 2 roots are not greater than or equal to a half. They're already out. So when you write your answer, you do it in either one of those forms, set or interval, okay? All right, questions on letter A? Letter B, letter B, letter B, letter B. Whisper words of wisdom on letter B. Set up the equation. R of X equals, boom, plug in. That was a check, you're welcome. R of X equals. All right, so what are we doing for the domain? Well, I spy a couple of things here. I spy a radical in the denominator, that's the square root. So 2x minus 1, the radicand has to be greater than or equal to 0. That gives you x is greater than or equal to a half once again. I also spy a denominator. What part of the denominator can't be 0? The entire thing. The entire thing can't be 0. Now look at the numerator. I spy a radical in the top as well, but guess what the root index is? It's a 3. Can we have negatives under a cube root? Yes, we can. Can we have zeros under a cube root? Yes. So if you see an odd root index, unless it's in the denominator, where you might get a 0, you're just waving at it. What's up there? How you doing? Good to see you. We're downstairs working. Don't mind us. No restrictions at all. It's a cube root, okay? So now when we solve this radical equation, this is where the wheels came off for some people. How to solve a radical equation properly. You have to first isolate the radical. Some people just got rid of the radical. Some people just distributed the 3 inside. Some people squared both sides right now and did FOIL. No, you get the radical by itself if you can. Add 6 to both sides. Divide both sides by 3. Oh, that works. So you get the radical now does not equal 2. Is the radical isolated? Yes. Now you square both sides. You get 2x minus 1 can't equal 4. Much easier. Add 1, divide by 2, x can't equal 5/2. But you do have to check for extraneous solutions, right? There's the red flag. Does 5/2 actually cause a 0? That's what you're checking. Does it actually cause a 0? Okay, 5/2 times 2 is 5. 5 minus 1 is 4. Square root of 4 is 2. 2 times 3 is 6. 6 minus 6 is, in fact, 0. We caught it. Now we need to exclude it. 5/2 is bigger than negative or positive 1/2. So when you write your domain, you could do it in set notation or in interval notation. You start at a half, step over 5/2, and go to infinity. Okay? Now, we did mention in class, it was subtle, but we worked a couple. There is a way for you to tell if your solutions are going to actually cause 0 and not be extraneous versus not really cause 0 and be extraneous. Look at your two terms. You have subtraction, right? You have a positive term. That's a positive 3 times anything that comes out of the radical is going to be positive. A positive number minus a positive number, that makes it smaller, right? And so it can be 0. When you have subtraction, it can be 0. Two numbers, when you subtract them, can be of the same magnitude, and it could be 0. That's how you know that your answer is going to actually cause a 0, meaning it's not extraneous. You do need to exclude it. All right, so you had one check for the setup and one check for the inequality. All right, now let's look at part C. Set up the equation, W of X equals, throw in your equations. We kind of have the same thing going on here now. A denominator with the square root. So 2x minus 1 is greater than or equal to 0 again. X is greater than or equal to a half. That's the same. Now the entire denominator can't be 0. Look at it though. I have a plus sign here. A positive number, positive 4 times the radical, plus another positive number. When you add two positive numbers together, are you going to get 0? No. So if you write that, you don't have to go through and try to do the algebra. I want you to think. That's the whole purpose of math education. So when you write this down, if you just say no real solutions, I get it. Now maybe you don't see it right here. Maybe you have to actually bring the 9 across. And then you're looking on the left side and you're like, hey, the left side is always a positive number, right? Positive 4 times the radical is 5. Is a positive number ever going to equal a negative number? No, that's never going to happen. So there's no real solution. If you absolutely need to keep going, here's what it would look like if you kept going. I would divide both sides by the 4. So you get the square root of 2x minus 1 cannot equal negative 9/4. Now I've isolated the radical, and now I'm going to square both sides. Square this side, raise a red flag or a blue flag. And now you get 2x minus 1. And here's why you know it's going to be extraneous. What happens to the negative sign when I square it? It becomes positive. So negative 9 times negative 9 is positive 81. 4 times 4 is 16. It's now a positive number. And if you add 1 to both sides, you get 81/16 plus 1, which is really 16/16. So you're going to get 2x cannot equal, what does that give you? 97/16. And then all you have to do is either divide both sides by 2. Whenever you divide a fraction by 2, you double the denominator, or you multiply both sides by a half, but you get x cannot equal 97/32. Okay? And then all you got to do is check, plug that in up here, and ask yourself, does it actually cause a 0? And you'll find out that it doesn't. So why did I make that number uncomfortable? Because fractions are numbers too. But I wanted you to realize, perhaps, that you didn't need to do all that work because you know when you add two positive numbers together, you're not going to get 0. Okay? So this one does end up being extraneous. All right, so you don't have to omit it. Questions on that one? All right, then the last one. This should be like easy money. This is like me handing you like a $100 bill as you walk in, okay? And then as you walk out, I ask for 99 back. Can you give me 99 back? I really only meant to give you a 1, but I gave you 100. You know, I'm a teacher. Numbers aren't my forte. Right. Where would I get $100 bills for every single one of you? My printer downstairs in my house. Print it. Counterfeiter. Uh-oh, if the feds hear this, we're busted. Yeah. Actually, on campus, I think it's okay, right? They'll just slap me on the wrist and let me go, right? Just like they did the guys that destroyed the bathroom up here. Instead of throwing them in the slammer, they just come back the next day. Right. Don't do it again.
Yeah, those are very comparable crimes.
Right. Right. Mine was victimless. There's the victim was every boy that had to go in there and see it. No, don't do counterfeiting. The guys that are in charge of the counterfeiting was originally the Secret Service. They weren't originally to protect the president. They were originally established by the one and only Abraham Lincoln to ward off counterfeiters. Okay. All right. So this problem should be money in the bank, real money in the bank. Okay. Not even like Bitcoin money in the bank, real money, like tangible money. But greenback, so there's that tangible. I'm talking gold standard, baby. Okay. H of x plus v minus h of x over v. Your function is 2 input squared plus 2 input plus 3. In the first one, I'm plugging in an x plus v. Minus the next one is just plugging in an x for x. So it's the actual function all over v. That's a check. A lot of people are getting the 7th check. That's great. Some people are still putting minus and then not putting parentheses nor distributing. And I'm like, why would you do that at this point? Don't. Okay. Now, when you expand it all out, look over here. When you square, multiply, double square, you double the middle term. Some people are missing that. Square, multiply, double. XV doubled is 2XV times the 2 gives you a 4. Some people had a 2XV down here because they did it in their head. And I'm guessing they distributed the 2, but they forgot the double. Square, multiply, double, square, right? Square, multiply, double, square. Distribute the 7, distribute the negative. At this point, everything without a V in the top should cancel. I highlighted the stuff that cancels. Make sure it does. Make sure they're opposite signs. At this point, you could go straight from here to here. But if you don't show this step in the future, you'll have it on the retest. You'll have it on your next test. If you don't show me the factor out step, I'm not going to give you the 8th check, even if it's correct. Ooh, almost caught it. Good catch, Floor. So they divide out, and you're left with 4x plus 2v plus 7 in any order. That was your 8th check. Okay, we did it. We got through the test. There's about a minute left. I'll be here every morning. I do have duty after school today. Watch the video. It's going to be in the shared folder right after this class. Practice, practice, practice. Okay. If you think you're good, finish your domain worksheet. It's due by 9 tomorrow. We'll grade it when you get to class, and then we'll jump back into 2.1. Okay. Have a great, super awesome, wonderful rest of your afternoon.